Jai Shri Krishna Mitro. Last time we can study about the some intermediate like carb cation, carb anion and free radicals. Now in this lecture we can study the new intermediate, reaction intermediate. The name is carbene. Carbene intermediate. What is the formula? What is the characteristic of carbene? First of all, carbene means one carbon which can have two sigma bonds and two electrons. It is not a lone pair. It is not a lone pair. So this type of arrangement is known as carbene. Carbon connected to two sigma bonds and two unpaired electron. This unpaired electron is not a lone pair. Clear? Why it is not a lone pair? We can clearly understand in these topics. First of all, it can have 1, 2, 3, 4, 5 and 6 electron in a valence shell of carbon atom. If we can have a carbene, then carbon has 6 electrons in its valence shell. Clear? Yes, no doubt it is a neutral species. There is no charge on carbene. It is a neutral species. No gain or no accept the electron. Generally, it cannot gain or accept the electron. It is neutral species. But it can have an incomplete octet. But it can have an incomplete octet. Because in octet there is requirement of 8 electron. Here 6 electron. Therefore, we can say that it is also electron deficient species. It is also electron deficient species. And it is electrophile. Electrophile means attracted towards the electron. It is attracted towards the electrons. Clear? It behaves as an electrophile. Highly unstable. Yes, it is no doubt very highly unstable and have a very short life. Clear? It is the examples of carbene intermediate like that. CH2, 2 electron, CCl2, 2 electron, C 2 electrons I and Br, C6H5C, 2 electron and H. It is a methyl carbene, it is a dichlorocarbene. There is a no name generally, chloroiodo, bromo, carbene, whatever. Here a phenyl carbene. Clear? CH2 dot methyl carbene, C6H5C dot H, phenyl carbene, dichlorocarbene. Generally, if we can think about the carbene have 2 sigma bond. It formed 2 sigma bonds. The carbene no carbon hoy, the carbon of carbene, it can form 2 sigma bonds and 2 electron is non-bonded. And these 2 electrons is non-bonded and it is not a lone pair. Not a lone pair. The non-bonded electron say lone pair nathi. Clear? It is a only and only non-bonded electron. Clear? Next, what is the use of carbene intermediate? We can use carbene intermediate in the following reactions like Riemann-Tiemann reaction and carbyl amine reaction. Riemann-Tiemann reaction and carbyl amine reaction. Clear? Now, if we can study the carbene in detail, we can say that there are 2 types of carbene, singlet carbene and triplet carbene. Now, we can study with the help of too many difference in singlet and triplet carbenes. Clear? So, we can start the types of carbene, singlet and triplet carbene. Clear? Now, we can classify the carbene with respect to 2 types, singlet carbene and triplet carbene. What is the difference in singlet carbene and triplet carbene? Difference of singlet carbene and triplet carbene is nothing but in the arrangement of non-bonded electron. Non-bonded electron ની જે arrangement છે ત્યાંથી singlet and triplet carbene different થાય. We can understand this. If you can think about singlet carbene, it is represented as dot CH2. It is also dot CH2. Hybridization of the carbon in singlet carbene is sp2. Otherwise, hybridization of carbon in triplet carbene is sp. Why? We can understand. Because in singlet carbene, carbon is form bond according to the ground state electronic configuration 1s2, 2s2, 2p2. 1s2, 2s2, 2p2. It is a 2s2, it is 2p2. Clear? Then it can undergo the hybridization sp2, 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 and one p vacant is a one p orbital is a vacant. Clear? One p orbital is a vacant. So carbon non-bonded electron HH. If we can represent in the orbital diagram, it is carbon, it is p orbital, it is hydrogen overlapping sigma bond, p orbital, hydrogen overlapping sigma bond. One p orbital have both electron. One p orbital have both non-bonded electron. In another language, we can also say that it is nothing but lone pair. It is nothing but lone pair, and one p orbital is a completely vacant. One p orbital is a completely vacant. Clear? So shape is bent or V shape. If you can think further, then we can say that it is a lone pair to bond pair. If we can say that, if anyone can say that, in singlet carbene, what is the structures or formulas? It can have two bond pairs, one lone pair and one vacant p orbital, which we can represent here. Clear? One vacant p orbital. The main characteristic of singlet carbene is that two electrons are present in a one orbital, therefore it is called singlet carbene. Clear? The two non-bonded electrons are present on a single p orbital and one p orbital is vacant. It is diamagnetic in nature because both electrons are paired. Clear? It is generally represented as CH2 orbital and paired electron, one is vacant, or also like that pair orbital or pair orbital. Clear? Sorry, pair electrons. That is represented as like that. Now if we can think about the triplet carbene, it is sp hybridized, carbon is ground state 1s2 2s2 2p2, we can say that. But in triplet carbene, carbon forms a bond with respect to excited state, which is 2s1 2p3. Clear? 2s1 2p3. Now it undergoes the sp hybridization. Clear? So it is carbon, hydrogen, sigma bond. One electron is present in a py orbital and one electron is present in a pz orbital. Here the difference is that here two non-bonded electrons are present on the same p orbital. Here two non-bonded electrons are present in a two different orbitals. So it is called triplet carbene. Clear? What is the difference? In singlet carbene, two non-bonded electrons are present on the same p orbital, but in triplet carbene, two non-bonded electrons are present on the different p orbitals. Clear? So shape is linear because it is like that. Shape is linear. It is paramagnetic due to the unpaired electron, and it is represented as CH2 electron CH2 electron or CH2 electron, and they both electron have the same spin. If one is plus half, then second one is also plus half. If one is minus one half, then second one is also a minus one half. Clear? So it is formed due to the ground state electronic configuration, is formed due to the excited electronic configuration. In this arrangement, hybridization is sp2, here sp, here bent shape, here linear, diamagnetic, paramagnetic. Both non-bonded electrons are present on the same p orbital. Both non-bonded electrons are present on a different p orbital. It is singlet, it is triplet, diamagnetic, paramagnetic. Two sigma bond, one lone pair and one p orbital is vacant. Here two sigma bond and two p orbitals have a two unpaired electron. Clear? So it is the main difference. Now we can discuss further difference between singlet and triplet carbene in detail. Now the another difference between singlet and triplet carbene is singlet carbene violates the Hund's rule, means does not follow the Hund's rule, while triplet carbene follows the Hund's rule. Clearly we can remember it. Singlet carbene violates the Hund's rule, where triplet carbene follows the Hund's rule. Next point is, it is a hot methylene, it is a cold methylene. It is a hot methylene, it is a cold methylene. If you can calculate the total spin stat of the singlet and triplet carbene with the help of formula, it is like that. Spin stat is equal to 2s mod plus 1. Clear? It is a formula. Mod of 2s plus 1. Mod of 2. Now the spin is plus 1 up 2 and minus 1 up 2. Because both have different spin. In singlet carbene, CH2, it is like that. One is plus half, second one is minus half. Therefore, it is 0. Therefore, only one spin state are there. Therefore, we can say that it is singlet carbene. If we can calculate the spin state in triplet carbene, it is like that. 2s mod plus 1. Here both have same spin. Here plus half, here also plus 1 half. Plus half is 1. 2 cross 1 is equal to 1. 2 plus 1 is equal to 3. Therefore, you can say that it is a triplet carbene. The reason of singlet and triplet carbene is a spin state. It can have a total 1 spin state. It can have a total 3 spin state. Now, if we can compare the stability of singlet and triplet carbene, therefore you can say that triplet carbene is a more stable and then singlet in the type of CH2 ... જો આ ટાઈપની કાર્બન હોય તો અમે સિંગલેટ કરતા ટ્રિપ્લેટ કાર્બન વધારે સ્ટેબલ છે. The reason is that if we can draw the singlet carbene, it is like that, and it can have a 103 bond angle between the two bond pairs. Therefore repulsion is more. If we can draw the triplet carbene, it can have a 180 degree bond angle in between the two bond pairs. Therefore repulsion is less. Repulsion is less, therefore it is more stable. Here repulsion is high, therefore it is less stable. If we can have a methylene type carbene, then which type of carbene is a more stable, singlet or triplet? Therefore you can say that it is triplet because of the less repulsion and more bond angle between the bond pairs. In this structure, bond pair have a maximum repulsion due to the less bond angle, and it is unstable as compared to the triplet carbene. It is a very simple. Now we can think about the production and characteristic of carbene. Now we can discuss about the stability of carbenes. If we can have a methylene carbene, triplet carbene is a more stable than singlet carbene. But if we can have a carbene of chlorine, bromine, then in the case of all halogens, singlet carbene is a more stable than triplet carbene. In case of bromine, chlorine, iodine, fluorine, in all halogens. If we cannot have a halogen containing carbene, then triplet is more stable than singlet. If we can have a halogen containing carbenes, then singlet is more stable than triplet. It is we can discuss in last. What is the reason why singlet carbene is a more stable in halogens than triplet? The reason is that if we can have a singlet carbene, then two non-bonded electrons are in a 1p orbital and 1p orbital is a vacant, and we all knows that all halogen have a 3 non-bonded lone pairs. 3 non-bonded lone pairs. From these 3 non-bonded lone pairs, it is 2p, it is of the 2p, sorry, it is of the 4p orbital and it is of the 2p orbital. Is the 2p orbital of carbon? It is the 4p orbital of bromine. Clear? It can donate the electron to the vacant p orbital, and this phenomena is known as partially donation or back bonding. It is partially donate the electron to the vacant p orbital, and this phenomena is known as back bonding. And back bonding, according to the back bonding, this is a partially formation of pi bonding, therefore it is a stable. Back bonding means એક બોન્ડ બની ગયા પછી ફરીથી વેકેન્ટ ઓર્બિટલને બ્રોમિન ઇલેક્ટ્રોન ડોનેટ કરશે પાર્શિયલી અને એક બોન્ડ જેવું ફોર્મ કરશે જેને બેક બોન્ડિંગ થયું કહેવાય. ઇટ ઇઝ ઓલ્સો એ પાર્શિયલી પાઈ બોન્ડિંગ. વન બોન્ડ તો હતો જ, સેકન્ડ બોન્ડ આ વન તો હતો, સેકન્ડ બોન્ડ પાર્શિયલી ક્રિએટ થયો લાઈક પાઈ બોન્ડ, બરાબર. સો singlet carbene is a more stable than triplet carbene in case of halogens. Clear? Because it can have a back bonding. If we can think about triplet, then it cannot generate a big bonding because both have a 1 electron, non-bonded electrons in its p orbital. Clear? So there is no partially donation. Now if we can compare the stability of this in this halogens according to the carbene of singlet, therefore fluorine, chlorine and bromine, then iodine, carbene have a stability in the order of first most stable carbene is a fluorine, then chlorine, then bromine and then iodine. Yes, if there is no clarification of singlet and triplet carbenes, then we can assume singlet. It is like that. જો આપણને ક્લેરિફિકેશન જ ન કર્યું હોય કે સિંગલેટ કાર્બન છે કે ટ્રિપ્લેટ કાર્બન, તો આપણે શું એઝ્યુમ કરીને આગળ વધશું? આપણે એઝ્યુમ કરીને આગળ વધશું સિંગલેટ કાર્બન છે. તો સિંગલેટ કાર્બનની સ્ટેબિલિટી સૌથી વધારે CF2 પછી CCl2 and CBr2. ક્લિયર? reason is that it is a 2p 2p because આની 2p આની પણ 2p, ફ્લોરિનમાં 2p હોય, આની 2p જ્યારે આની 3p, આની 2p જ્યારે આની 4p. જેમ ડિસ્ટન્સ વધતું ગયું ઓર્બિટલ વચ્ચે એનર્જીનો ડિફરન્સ થતો ગયો એમ બેક બોન્ડિંગ વીક બનતું ગયું. આમાં બેક બોન્ડિંગ મેક્સિમમ થાય because both have 2p orbital. Here one have a 2p, another have a 3p, here one have a 2p, one have a 4p. Therefore back bonding is a weak and stability is a less. So remember that. Now we can think about the generation of carbenes. Formation of carbene. First of all we can remember carbene is not a product, it is an intermediate. It is a very short, it can have a very short life. First of all you can remember this point, carbene is not a product, it is an intermediate which can have a very short life. It is generated from the help of or with the help of generally 3 types of reaction. First of all we can think about the reaction of acid and base. Reaction like acid and base. If we can have a chloroform CHCl3 and we can give the reaction with strong base like KOH or NaOH or ethoxide or alkoxide. In short, alkoxide ions or phenoxide ions. It is a strong base. Then the mechanism is like that, and we can get the product like that. First of all, we can draw the chloroform like C, Cl, Cl, Cl and H. Generally, carbon attract the electron pair from the hydrogen, it can have a plus charge, and this H plus and OH minus from these ions connected to form a H2O, and it is released in the form of C minus carbon ion. Now, the positive radicals of this strong base like K plus and Na plus attracted the Cl, then Cl gets the lone pairs toward the because electronegativity of chlorine is more than carbon, therefore it can attract the electron pair from the bond, and it can make the bond with potassium or sodium. Here if we can have a sodium, then it is NaCl, and we can generate the singlet carbene like Cl, Cl dot dot. This electron is in the form of dot, which is dichlorocarbene. If we can have a different types of halogens, then the leaving group tendency is first iodine, then bromine, then chlorine and then fluorine. જો એક કરતા વધારે ટાઈપ્સના હેલોજન પ્રેઝન્ટ હોય તો ફર્સ્ટ કોણ લીવ થાય? આયોડિન, પછી બ્રોમિન, પછી ક્લોરીન ને પછી ફ્લોરિન. Now if we can think about these types of reaction, if we can have a CHF2Cl, we can have a strong base like hydroxide ion, amine or phenoxide ion, બરાબર? Here NH2 minus. We can have first remove the H. જ્યારે સ્ટ્રોંગ બેઝ સાથે રિએક્શન કરવામાં આવે તો OH ફર્સ્ટ કોને રિમૂવ કરી દઈએ? H ને. તો શું મળે? CF2Cl. H રિમૂવ થયો અને કાર્બન ઉપર કયો ચાર્જ આવશે? નેગેટિવ ચાર્જ. Now in the presence of positive radical like Na plus and K plus, if you have Na plus then NaCl, then K plus, then KCl is removed and we can get CF2. Why? અહીંયા જો બે ટાઈપના લેજન હતા F અને Cl, તો એમાંથી પહેલા કોણ લીવ થાય? Cl, because living aptitude of chlorine is more than fluorine. સમજાણું મિત્રો? તો પહેલા કોણ લીવ થાય? ક્લોરીન ને ફ્લોરિન બચે. નેક્સ્ટ આ એની મિકેનિઝમ હતી. ક્લિયર? કે પહેલા હાઇડ્રોજન લીવ થયો એટલે આપણને આ ટાઈપનું મળ્યું. હવે એમાંથી કોણ લીવ થાય? ફ્લોરિન ન થાય. કોણ થાય? ક્લોરીન. We can have a CF2 difluorocarbene singlet. Now if we can have a CHI2Br and KOH, જનરલી આવું આપી દઈએ પછી કે બ્લેન્ક કયો કાર્બન જનરેટ થશે, તો પહેલા તો આપણે હાઇડ્રોજનને જ રિમૂવ કરી નાખશું. યસ. હવે જુઓ, હાઇડ્રોજનને રિમૂવ કરશું એટલે આવું વધશે C, આની ઉપર નેગેટિવ ચાર્જ, 1I, second is also I, and third is Br. From this, which is leave the group, ટેન્ડન્સી કોની વધારે છે લિવિંગની? તો આયોડિનની. તો અહીંયાથી હવે એક આયોડિન રિલીઝ થાય, બચશે શું? તો કે એક I ને એક Br, એક I એક Br. ક્લિયર? નેક્સ્ટ CHFBrCl, H તો ગયો જ પહેલા. હવે કોણ કોણ વધ્યું? FBrCl, તો પહેલા કોણ રિલીઝ થાય? Br, તો બચશે કોણ? F અને Cl, F and Cl. ક્લિયર? નેક્સ્ટ CHBrCl2, તો હાઇડ્રોજન તો ફર્સ્ટ રિલીઝ થઈ જ ગયો. હવે કોણ રિલીઝ થાય? Br, તો બચશે શું? ડાયક્લોરો. ક્લિયર? So it is very simple. If we can have ask the question in the form of blanks or MCQs, we can very easily write down. Clear? Now we can discuss the second two methods to generate the carbene. Now the second method to formation of carbene is if we can have a compound diazomethane and we can carry out the pyrolysis or photolysis, we can get the carbene. If we can have a diazomethane means CH2N2, and we can carry out the pyrolysis or photolysis in the presence of photochemical light, in the presence of sunlight or commercial heat. CH2, the structure of CH2N2 is like that: CH2 double bond N, negative charge, positive charge. If we can heat it or we can have a sunlight, it can release the nitrogen and energy with the help of formation of singlet carbene. Clear? And last one is from ketene. Ketene means CH2 double bond C double bond O. If you can heat it, it can release CO, carbon monoxide, and carbene, singlet carbene CH2. Clear? Methylene carbene. So it is the very short information regarding to the carbene intermediate, how it can have generated, what is the properties, characteristic, formation, types, which we can discuss in a detail in this lecture. So practice it. In next lecture we can start the new points or new topics. Clear? So આજના માટે આટલું, વધારે next time.